Okay, so this video is the Unit 9 review. We'll do numbers 11, 12, and 13. So this is page 5. So in this one, let's see. If WX is parallel to YZ in this circle, so those two chords are parallel, explain why this arc, XY, and WZ have to have the same measurement, so they're the same number of degrees. So, they give you a hint, draw an auxiliary line. So I don't quite know what line to draw, but a good guess would be to connect a couple of points that are already in the picture. So let's try XZ and see what happens. So we created a couple angles, 1 and 2. So we'll do like a little mini proof here. So WX is parallel to YZ, that's the given. And then we drew in that XZ, creating two angles, angles 1 and 2. And notice angle 1 has to be congruent to angle 2 because they form that Z shape and the top and bottom are parallel. So this is parallel lines gives us alternate interior angles that are congruent. Okay, well 1 is an inscribed angle and 2 is an inscribed angle. So that opens up to XY. So we'll say XY is 2 times the measurement of angle 1. And angle 2 is also inscribed and it opens up to WZ. So WZ is going to be 2 times the measurement of angle 2. Since angle 1 and angle 2 are the same, XY and ZW have to be the same. So I'm just going to say measurement of arc XY has to be the same as the measurement of ZW or WZ because XY is 2 times the measurement of angle 1 and WZ is 2 times the measurement of angle 2 and angle 1 is congruent to angle 2. So that's how we get that those two arcs have to be the same. Let's take a look at 12. So in 12, we've got, we've got this 70-degree arc right here. And there's a congruent chord, congruent to this chord, congruent to that chord. Now remember, we learned a theorem that said if you have two chords that are congruent in a circle, then their arcs have to be congruent too. So those arcs would be the same. So if this arc is 70, then this arc is also 70 degrees. And this arc is also 70 degrees. So I'll just put this one right on the arc. So this one is also 70 degrees. So let's see, what can we do with this? Angle W here, if you look at W, if we draw that by itself, it looks like this, where the arc that it carves out is 70. And so this angle, since it's inscribed, is going to be half of 70. So W is going to be 35. X is right here. And if we drew X by itself, it's formed by a tangent and a secant. So here's X. And the arc that it carves out is 70. And since the corner is on the circle, we treat it just like an inscribed angle. So the X is going to be half of 70. So X is also going to be 35. Actually, I'll take off the degree signs. Let's see, angle Y. So here's Y. Y is also an inscribed angle. Right there. And that opens up to two 70s put together. So it opens up to 140 degrees. So Y is going to be half of 140, which is 70. And then Z. So Z we can do a couple different ways. Let me clear out some of this junk here. So this is 70. This is 35. Okay, so one of the ways we could get z is by doing 360 minus 70 and 70 and 70. So that's the easiest way probably. Minus 70 plus 70 plus 70 all put together. And that ends up being 150 degrees. Another way of doing it though, just so you practice another idea. Oh wait, does this work? Hold on. Oh yeah, sorry. Okay. So another way that you can do this, this arc is 70, we know. So this angle over here has to be 35 as well. So then you could solve for this angle in the triangle right here. And that angle ends up being 75. And then the 75 opens up to z. So z would be 150 then. So z would be 150. So that's another way of getting it. By the way, if I had asked in this problem, I'm just making this up now. But if I'd asked in the problem what this angle is, and I didn't tell you anything else except what's already in the picture, you could have gotten angles. You could have gotten this angle by noticing this quadrilateral is inscribed in the circle, and we learned a property that said opposite angles in an inscribed quadrilateral always add up to 180. So this one ends up being 110 if you had to figure it out. Okay, let's take a look at number 13. So 13, I'll just tell you right now, is a tricky problem. So one thing to note, we've got parallel lines over here. The goal is to get x, the distance between those parallel lines. So, and this QC is a tangent line. This is supposed to be the center of the circle, so the radius is 6. Now it says, think about a good spot to draw a new radius. Well, normally you want to connect to points that are already on your circle, and it looks like Q might be kind of an important point because it's also connected to this triangle that involves x. So if I draw on that radius, I know it's 6. And since it's a radius drawn to a tangent, I know that it's a right angle there. So this triangle right here is going to be a right triangle, and it turns out I already know 2 of the lengths for it. I know that this is 6, and that this is 6 plus 4, which is 10. So I could solve for this length right here. So 6 squared plus y squared equals 10 squared. And so if you work that out, you get y equals 8. So this length right here is 8, which also gives me a length in the triangle that it has an x in it. So here's the part that I think is tricky. We haven't used the fact that the lines are parallel yet. And if you use the fact that the lines are parallel, you might notice there's a Z shape right there where this angle and that angle would have to be congruent. So if you now look, I've marked one curve here in this triangle, and I've got a right angle here, right angle. Well, so I've got a right angle and a one curve. That matches the right angle and the one curve in the other triangle, which I'll draw right below it here, where I know that this one is 8 and this side is x. Well, these two triangles are similar. The triangles are similar because of angle-angle similarity. So that means I can set up a ratio. So let's see. I need the x involved. The x is between the right angle and the one with no curve. So that's going to be related to the 6. So I'll go x goes with 6 the same way that, and then let's take a look here. The 8 is the hypotenuse, so that's going to go with 10 in that one, the same way that 8 goes with 10. Then if I cross multiply, I get 10x equals 48. So if I divide by 10, I get 4.8. Now, there is another way of doing this. I don't think this is easier. You'd still need to know that these angles match up. But then if you don't realize that the triangles are similar, you could solve for this angle right here using inverse trig, like tan inverse of 6 over 8 will give you theta. And then you can bring that theta down here because these angles are the same. And once you know what that angle is, you can use trig because theta is some number now. And so you could use like sine of theta equals whatever x is over 8, and then you can solve for x that way. And you'll still get 4.8 as long as you keep all those decimals stored. All right, I hope that helps a little bit.